friends, and welcome back. In this video I want to show you how to use the mirror formula to solve problems, how you can apply it to problems, and it's going to be very simple. If you're having challenges in doing that, just keep watching this video. Given that 1 over v plus 1 over u is equal to 1 over f. So what are these parameters? The v is standing for the image distance, and the u is standing for the object distance, and f is for focal length. But there are conditions to which we apply these things. When we talk about convex mirror, in convex mirror, the image distance is always assigned, we always assign negative to the image distance for a convex mirror. You have to take note of that. But for a concave mirror, the image distance is always positive. Why are we doing so? Because the image distance for a concave mirror is always real. But for a convex mirror, the image distance is always virtual. All right. So if that be the case, let's see how we can implement these parameters into the formula. Let's quickly do that. But before we go about solving the problem, let's interpret the equation. The image of an object in a convex mirror is 4 centimeters. You can see the image of an object. So that is to say, V is equal to, we are supposed to write 4 centimeters. But remember, I just explained that for convex mirror, the image is always what? The sign is negative because the image is virtual. And when it is virtual, we add negative sign to it. Again, if the mirror has a radius of curvature to be 24 centimeters, find the object position and the magnification of the image. So we've gotten the parameters we need. And then in course of applying it to this formula, which is 1 over v plus 1 over u equal to 1 over f, you can see that f is not given in the parameters listed, and u is what you're looking for. Find the object position. So that is the u you're looking for. So firstly, we're going to make this the subject of the relation, and that will be 1 over u equal to 1 over f minus the whole of this 1 over v. How that makes sense? So in order for us to get this f, you just have to note that r is equal to 2 multiplied by f. And if r, which is the radius of curvature, is equal to 2 times the focal length, it means that the focal length will be equal to the radius of curvature divided by 2. Divided by 2 rather. So that means the focal length in this point will be, what is the radius of curvature? That is 24 cm. 24 cm divided by 2. And that will give us 12. But remember, it is a convex mirror, so it has to go with negative sign, negative 12 cm. So that is the value for our focal length. So here we have 1 over u equal to 1 over minus 12 minus 1 over the v here is minus 4. All right. Okay, so what will be the LCM of the denominator? Of course, you know that this negative sign will affect this to become positive. So this expression can still be written as 1 over u equal to 1 over minus 12 plus 1 over 4. So the LCM of the denominator is minus 12. So if here is minus 12, minus 12 goes into itself is 1. And 1 times 1 is 1. Plus 4 goes into minus 12, that will be minus 3. So minus 3 times 1 will give us minus 3. So we change here to be minus 3. So this is for 1 over u. 1 minus 3 will give you minus 2. Divide by minus 12. Of course, these negative signs will cancel each other. So we're having 1 over u equal to 2 over 12. So if we invert, because we are looking for this u, which is the position of the object. So if I take this up, I will have to reverse this. If I invert this term, if I invert the left hand side, I will have to do so on the right hand side. So at that point, I will have u over 1, which is the same thing as u, will be equal to 12 over 2. And of course, u over 1 is u equal to 12 divided by 2, and that is 6 cm. And this is the object position from the mirror. I hope that makes a lot of sense to you. Okay, and of course, seeing it like this, you should know that it is what? It is real. Then the next one, we are also asked to find the magnification of the object, of the image. Magnification can always be given as the height of the image divided by the height of the object, or the distance of the image divided by the distance of the object. So in short form, magnification will be equal to V over U, which is the distance of the image all over the distance of the object from the mirror. All right. So therefore, magnification will be equal to, what is V? V is minus 4 cm. Okay, at this point, we treat it as 4 cm the way it is from the equation. That is 4 cm, 4 centimeter, all right, over what is U? U has been calculated to be 6 centimeter. Centimeter, of course, we cancel out the centimeter. So therefore, instead of leaving it like this, 2 can go into this, which is 2 times. 2 goes into 6 3 times. So we have it to be 2 over 3. So this is the solution. This is the solution for these two problems, or this, what we are asked to find, the object's position and also the magnification. So I hope this makes sense to you. So if you are having any challenges in any of the concepts, please drop the question in the comment section. And again, if you've not subscribed to the channel, please hit the subscribe button. And I hope this video makes a lot of sense to you. Thank you very much for watching. I will see you in the next video. Peace.